All right, students. So we're looking here at our third number theory lesson where we're looking at primes and factorization. One of the nice things about integers is that every integer can be factored uniquely as a product of primes. And so that's kind of the idea of this section. And this forms the bedrock of a lot of later number theory stuff. So that's actually the fundamental theorem of arithmetic is that you can always factor an integer into a product of primes. So I'll just do a couple examples here, like 5040 um, ends with 0. So we can write it as 504 times 10. And then we can factor 10 to just be 2 times 5, each of which are primes. And now we want to look at the other number, 504. And you can keep just knocking down the number. If it's an even number, you can obviously divide it by 2. So what does that make? 252 times 2. That's another even number. So what is that? 126 times 2 times 2 times 2 times 5. And it starts to get a little annoying to keep track of all the 2's. So that's when I suggest using some exponents. So this is 63 times another 2. So I'll have a total of 4 2's and then 5. Let's see, 63 adds up to 9. So 63 is 9 times 7, right? Uh-huh. So 9 times 7 times 2 to the fourth times 5. Almost there. The number 9 is 3 squared. So 3 squared times 7 times 2 to the fourth times 5. Or I usually like to write them in ascending order of primes like this. By the way, as just a weird little thing I saw online, you may be familiar with different base notation like base 10 and base 5 and binary and base 8 and things like that. There's this notation I saw which is called primal notation. Oops, I guess I flip flopped the 5 and the 7 there. And primal notation is this weird idea where each digit's place value is the power of that prime. And so I could write this number like this in base primal. And this is just saying, right, 2 to the fourth, 3 to the second, 5 to the first, 7 to the first. And because of the fundamental theorem of arithmetic, every integer could be written in primal notation. Okay, great. The rest of those are pretty straightforward, so I'll skip along there. All right, let's look at something on the next page here. So let's look at this. So let p be an integer other than 0 and positive or negative 1. Prove that p is a prime if and only if, so we need to do both directions. Whenever r and s are integers such that p equals rs, then r equals plus or minus 1, or s equals plus or minus 1. So let's try to assume the first direction. So we're going to say assume p is prime. So then let p equal r times s. And because p is prime here, we know that the only factors of p are p, negative p, 1, and negative 1. So that means that the possibilities for r are p, negative p, 1, or negative 1. And the same thing goes for s. So let's just go through each of those cases. So if r is equal to p, then that means p equals r times 1. If r is equal to negative p, that means that p equals r times negative 1. So in these two cases, we see that s is equal to positive or negative 1, which is what we wanted to prove. Same idea with the third and the fourth case. If r equals 1, then p equals r times p. And if r is equal to negative 1, then p equals r times negative p. And in each of those cases, r is equal to plus or minus 1. And so that checks it off and proves that those are the only possibilities because p is prime. And so we knew that it would either be one of these four factors. That's the definition of prime. All right, now let's try to prove the other way. So assume p equals rs implies that r or s are plus or minus 1. Okay, so let's just go through the same r values right there. So if r equals 1, then that implies p equals 1s, which implies that s is equal to p. If r equals negative 1, p equals negative 1 times s, which implies that s is equal to negative p. And so the same argument for s equals plus or minus 1. Thus, the only factors of p are plus or minus 1 and plus or minus p. And that means p is prime. And so there we go. So that may come up, a lot of times when you're doing these sort of problem sets, an idea that you prove early in the problem set comes up later. So just keep that one in mind as you work through some of these later problems. Comment or ask questions if there's anything else I can do, and have fun with the number theory.